Hi everyone, for this set of notes we're going to be learning how to factor cubics. So your essential question for this set of notes, what are the three main characteristics about a polynomial that allow you to know you are going to be factoring a cubic polynomial? The three steps to factoring cubic polynomials, you're going to identify a GCF if possible. If it's not there, you're going to skip the first step. Factor your remainder. That's also if it's possible, so you're going to be checking whatever you have left over in those parentheses if it's factorable. And then we're also going to look at the last step to check to see if we are able to factor either the sum or a difference of cubes. So some formulas, the one that you have already been familiar with was the difference of squares. This is where you had the perfect squares, a squared minus b squared. This is always a difference of squares. It had to have the negative sign right there, and it always came out to be the formula a minus b times a plus b. Again, you were able to switch the plus and the negative. It didn't matter where those values were as long as you had one positive and one negative. Now, the two new formulas that we're going to be using is a difference of cubes. Again, you have two terms in your original equation, and you will also have, instead of a 2, you're going to actually have multiples of 3. Going up, adding a number multiplied by itself 3 times. So we'll go over more examples of that, but you'll be looking for the 3's as well as other examples when I show you. However, the two terms, this is actually always going to be your formula that it's going to turn out to be no matter the signs. So as soon as you see that you have a negative sign and two cubes, you're always going to have a minus b and then a squared plus ab plus b squared. These signs are always going to stay the same. Then for our sum of cubes, again, the only thing that changes is the plus sign, and you're going to have these operations always. So instead of having the a minus b, it does turn to a plus b because you're using the sum of cubes, and then we have a squared minus ab plus b squared. These formulas are going to be what you need to memorize and get used to. We're going to be using them very much. So for our perfect cubes, what I mean by that is you have to figure out a number that's multiplied by itself 3 times to get you that value. So 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 is 20, times 3 again is 27, 4 times 4 times 4, 64, 5 times 5 times 5 is 125, and so on. For this x to the third, what I did here is I figured out a value that I multiplied 3 times. Remember, they have an exponent of 1 right here. So you want to make sure that your exponents are being added when you multiply the same bases. So this is just 1 plus 1 plus 1, and that's how I got the 3. So then for that x to the third power, what you're going to do is, x to the sixth power, you would have x squared times x squared times x squared. So again, if you added those exponents, 2 plus 2 is 4, 4 plus 2 is 6. And that's the same thing for that x to the ninth power. You would have x to the third, and then x times x to the third, and then times x to the third, adding those exponents again. 3 plus 3 is 6, 6 plus 3 is 9. So for our first example we're going to go over is 6x to the third power plus 9x squared minus 12. Our very first step is to identify if there's any GCFs. So I do see that we have a 6, 9, and a 12. So I know that 3 will be my GCF, and now I'm going to write my remainder. So, sorry, not x. You have a 2x to the third plus 3x squared minus 4. So again, I just divided 3 out, so 6 divided by 3 is 2, 9 divided by 3 is 3, negative 12 divided by 3 is negative 4. Now this is the second step. I'm going to check to see if this portion in the parentheses is still factorable. So I'm going to go ahead and identify my a and my c, which is 2 times negative 4, which is a negative 8, and then I'm putting my b term, actually you can't even do that. You can only do this process, you guys, if you have a squared right there. Okay, so this actually isn't going to be factorable. So my final solution is 3 times 2x to the third plus 3x squared minus 4. Close your parentheses, and that's your final solution. I cannot factor this because it's not a polynomial or not a quadratic, so therefore I cannot actually use the AC method with that. For our next example, we have x to the third plus 2x squared plus x. Again, first step, take out a GCF. I see that I have an x as my GCF. It's in all three terms, so that's my value. I have an x squared plus 2x plus 1 left over. Now I do actually have a polynomial that is a squared, so that is a quadratic. So now I do get to use my AC method. So my coefficient is a 1 right there. I'm trying to figure out what two numbers multiply to 1, but then add to 2. Okay, so I know that 1 times 1 is 1, and then 1 plus 1 is 2. So my values I get to write, since this actually has a coefficient of 1, you get to use the parentheses like this, and you actually get to do x plus 1 and x plus 1. This would be the same way if you guys did the factor by grouping way, so we'll start getting really good at these. So this is my final solution, x times x plus 1 times x plus 1. You can also rewrite it like this, x plus 1 squared. So I would accept either of those answers. It's just saying that you wrote this portion out twice. For our next example, x to the third power minus 27. So here are some of the characteristics of us being able to factor a cubic. So first of all, I have two terms. Awesome. I know that this is a perfect cube because x times x times x gets me x to the third. And I also know that this is a perfect cube because 3 times 3 times 3 gets me 27. So when I have my perfect cube, I have a difference of cubes on this case. So my formula that I have here was let's actually write this out so you guys can be familiar with it. So we have a to the third minus b to the third. So that's the case that we have here. We're getting our difference of cubes. We're always going to have a minus b times a squared, whatever that first term is squared, plus ab, so first term times last term, plus our last term squared, which is b squared. So we need to figure out what that first term is, so that this is my first term. So we just said that the perfect cube of x to the third was x. Okay, let me actually write this out here so we can see what we're doing. So x to the third minus 27. So this is our formula, allowing us to know that we have a difference of cubes. So x was my first term. So basically we're allowing a to equal x in this case, and then b, our perfect cube for 27, was 3. So now anywhere I see an a, I'm going to plug in x. Anywhere I see a b, I'm going to plug in a 3. Okay, so I've gone through and I've plugged them in. There's some weird things like writing here. I don't really like having my number after the x because with coefficient, the number goes first. So now I'm just going to kind of clean this up. So x minus 3, there's nothing to clean up there. X squared, nothing to clean up there. This 3 and this x need to be swapped so that the coefficient's actually in front of there. And then if you ever have a number like this 3 squared, actually square it. 3 times 3 is 9. Okay, and the last thing we want to double check that this quadratic right here is not factorable anymore. So it has to multiply to 9 but add to 3. So 3 times 3 is the only one, or 9 and 1. That gets you factors back to multiply to 9, but not added to 3. So I don't actually have to factor this because there's nothing factorable. So now my final solution is this. Now for our last example, again, first step, you're going to look for a GCF. I see that I have an x in both of my terms, so I know that I'm going to have an x be factored out, and then left with an 8x to the third plus 27. And at first, if I started off with a 4, I'm like, hey, I only have 2 terms, but I'm going to be checking to see if it's a factor, a sum, or a difference of cubes. So when all of a sudden I take out that GCF, that probably means you have to take out a GCF. Now look at, I actually have cubics. So 8 is 2 times 2 times 2, x to the third is x times x times x, and that 27 is 3 times 3 times 3. So I already have my GCF. Don't forget about this guy right here. We're going to get back to him later. But now I'm going to work with this value here. So this time I have a plus sign. So now I'm going to go ahead and write out the plus formula. So we have a to the third plus b to the third equals a plus b. So again, you're always using this formula. A squared minus a times b plus b squared. So now with this value here, I'm going to identify what my a term is. So my a equals, so it's going to be the whole thing, that value of 8, so that was 2, with perfect cube 8 was 2. Perfect cube of x to the third was x. My b value here, if we have the 27, the perfect cube of 27 was 3. So now anywhere I see a 2x, or sorry, an a, I'm going to plug in a 2x. Anywhere I see a b, I'm going to plug in a 3. And I like putting this thing in parentheses here just because it helps me remember what I'll be multiplying. And then here we have 2x times 3, and then plus 3 squared again. You can put those in parentheses too. So now let's just, now that we wrote everything out, we literally plugged it all in, let's clean it up. So we have 2x plus 3, and then this squared, be careful because it's not just 2x, or sorry, not just x squared. You have to make sure that that is 2 to the second power and x to the second power. So 2 to the second power is 4, x to the second power is just x to the second power. Now minus 2 times 3, which is 6x, and then that 3 squared is 9. So that is our final example here. This, just double check this again, it'd be 4 times 9. So what multiplies to 36 but adds to 6? So 6 times 6, and you can do 3 times 12, but none of those are going to get me added up to 6. So again, I cannot factor out, and this is my final solution. And that's it for today.